Okay, so we're going to be looking at resistance in circuits, and I just want to explain, because we've had a look at what resistance is, or we've had a look at how to measure it, but now we're going to look at actually what it is. So this is a little diagram that shows a wire. We have our copper nucleus, or any wire at all. I mean, copper is the one that we use the most because it is quite cheap and it is quite conductive. But things like gold are used in mobile phones, and they're more expensive, so you wouldn't get gold wires even though they're far more conductive than copper. And we say that this is a positive ion because the electrons, when there is a potential difference, the electrons flow through the wire. Now these little yellow balls that are zooming through the wire, they are our electrons. They are little balls with the little negative in them because electrons are negative. So what is then resistance? Well, we've got to unpick a few things here to understand why the rate of flow of charge decreases, why the current decreases if resistance increases. And it's basically because my negative electrons collide with the positive ions in the wire. Now, a reminder here about the kind of energy that's in anything that is moving. We talk about kinetic energy. So kinetic energy, which I shall abbreviate to EK, is in any object that's moving. My electrons are flowing through the wire. Now, when my electrons collide, so I'm going to draw in an electron here, and when that electron collides with the positive ion, then some kinetic energy is also transferred to my positive ion. That causes the kinetic energy of my positive ion to increase as well. There's a transfer of kinetic energy from the electron to the positive ions. So the electrons collide with the positive ions, the nuclei of the wire, the metals in the wire, and transfer some kinetic energy to them, causing them to oscillate more because their kinetic energy has increased as well. And remember, oscillation just means vibrate, and this increases the resistance. Now, this statement here, electrons collide with the positive ions and transfer energy to them, causing them to oscillate more, thereby increasing the resistance. That was actually a 2-mark question in, it was a 2 or a 3, it was either a 2 or 3-mark question in 2018. And this was the exact wording that they gave in the GCSE. So it's worth learning this just by rote. Now, we have an equation that we can use to describe this. We have voltage is the push given to the battery, or by the battery, pardon me, not to the battery, by the battery. The greater the push, the greater the current. Resistance stops the flow of current. Resistance interferes with the flow of current. So this idea of flow of electrons and this idea of those electrons colliding with positive ions and therefore losing some of their kinetic energy, they're all linked together with how much push is coming from the battery. So pause this video and try and decide which 3 variables you would need in the equation. Okay, so obviously we're going to get potential difference, we're going to get resistance, and we're going to get current. These 3 things can all interlink to describe a mathematical relationship about the flow of charge in a circuit. Now, Ohm's law can be written as this: V equals I times R. The voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions such as temperature remain constant. This is important because if we increase temperature, then we're going to increase the amount of kinetic energy in my ions, and so therefore we're going to increase the resistance as well, almost always. That is not a hard and fast rule, but it is a good generalization to think of. Increase resistance, then you increase, increase temperature, then you increase resistance. So the voltage across a conductor is directly proportional to the current flowing through it. All that means is if I have got 1 volt in my circuit and that makes 2 amps, then 2 volts will make 4 amps and 3 volts will make 6 amps. So we get a little bit of a pattern forming. This pattern is directly proportional. What does directly proportional mean? For every increase in one variable, you get the same step in the other variable. Not the same increase, but the same step every time. Increase by 1 volt, you'll increase by 2 amps. So potential difference can also be written as voltage. It can also be written as PD or PD. Potential difference the symbol for that is V. The units are volts with the unit symbol of V. Current, the symbol for that is I. The reason for that is it used to be called the intensity of flow. So we use I for current, the rate of flow, measured in amps after Ampere, who was the scientist who discovered it, and the unit symbol is A. Resistance, symbol for that is R. The unit is ohm, and its unit symbol is an omega. So it's just it's like a horseshoe. You know, it doesn't really matter how you write it, as long as it's got this vague shape. What I'd like you to do is pause the video, give this a go, see if you can figure it out. And when I finish speaking, I'm going to write down the rearranged equations for everybody. So you can pause now if you don't want those. If you want the rearranged equations, V is equal to I times R. If I want to arrange that, if I want to change the subject for I divide across by R. So V over R equals I. If I want to do it for R, pardon me, R is equal to V over I. And I'll write this one up here for you as well, just so it's nice and clear. Okay, pause this video and give a go at some of these questions. All right, so milliamps, kiloohms, milliamps, kilovolts, and millivolts. All right, make sure that you, if you've done amp standing, you can check that very quickly. Remember to go from milli to your standard SI unit, we're going to divide by 1,000. And to go from kilo to your standard SI unit, you're going to multiply by 1,000. If you were doing outstanding and you want to pause, you can do that. And here are your answers. Right, so measuring resistance. Hopefully you'll have done, or you will be doing, an experiment to measure the resistance of electrical components. Now, all that means is you're going to have a source of potential difference. You're going to have an ammeter to measure the current, a voltmeter to measure the voltage across the component you're looking at. When we have our ammeter set up in series, then that will measure the current, the intensity, and when we have a voltmeter set up in parallel, that will measure the voltage. Now, you can use something called an ohm meter to find resistance, but they're quite expensive, so we don't do that at school. Instead, what we do is we measure the voltage and the current, and then we use the equation V equals I times R to find the resistance. So we measure the current and the voltage with an ammeter and voltmeter respectively. We use this equation, R equals V over I. And the component that we use, it can be any component that you like. So here we've got a resistor, here's a variable resistor. You could put in a filament lamp, or you could put in a diode or any other component that you can think of. Now, a variable resistor will change its resistance. So it's basically a long loop of wire with two contact points kind of embedded in there, and that contact point will go to the negative and that will go to the positive, or if it's an AC, it'll just go to two different ports, and we can actually move one of those sliders up and down. Longer wires have got more resistance, so if we move it towards the contact point, we decrease the resistance, and if we move it away from the contact point, we increase the resistance. Now, this you will do in school, so don't panic. We will show you one of those, but for now, we're just going to have to move on. If you want to get different ranges at school, instead of us using a variable resistor, we can also change the PD, so we can alternate the voltage coming out the battery. Okay.